Hello folks, here we have your beloved study guide tutorial videos. And here's page 1. So we'll jump right in. This is on your Conics test. Number 1 says write an equation for the parabola with a focus of -1, 1, and a directrix of y plus -7. Well, the first thing that we need to do is figure out which direction is this parabola facing in order for us to know which equation of it we're going to use. We have to know, kind of the orientation of it. So if I just go out to the side real quick and I kind of sketch where this focus and directrix might be. So let's say, okay, so if I have an x and a y axis, the focus is at -1, 1. So this is a focus. And then the directrix line is y equals -7, which is going to be way down here. So if that's the directrix and that's the focus, our parabola can't touch this directrix line, and the focus has to be on the inside of it. The only way for that to happen is for our parabola to face up. So if that's the case, then we must have the x squared, or the x term, be the one that is squared, and p must be positive in order for that to happen. Okay, so using that going forward, we can kind of look at the equations and the formulas for the x squared parabola. So first of all, a focus in a parabola is found by h comma k plus p, and the directrix is found by y is equal to k minus p. So then, if I take both of these equations, so I notice I have k plus p and I have k minus p is equal to something. So if I take these equations and kind of bring them off to the side and make a system, I can solve them. So if I say, okay, k plus p is equal to 1 and k minus p is equal to -7, then I can add this system and solve, and I end up with k plus k is 2k, negative p minus p cancels, and 1 plus -7 is -6, which implies if I divide both sides by 2 that k would equal -3. So I've successfully solved for k. In order to finish writing the equation for the parabola, I would need, let's see, I've already got h, k, I need to solve for p. So again, if I know that k is equal to -3, and I know that 1 is equal to k plus p from this expression right here, then now that I know what k is, then I can say, okay, 1 is equal to -3 plus p, and to solve for p, I add 3 to both sides, and I get p is equal to 4. And that's all I needed. So then we knew again that we're using the x squared version of our parabola. And if we do that, that's going to be x minus h squared equals 4p times y minus k. So again, I already had h in the problem. I solved for k, and now I have p. Therefore, I can substitute those values in. X minus -1 will be x plus 1 squared is equal to 4p, so it'll be 4 times 4, times y minus k. Y minus -3 will change to y plus 3. Then, of course, we want to go ahead and simplify, so we end up with x plus 1 squared equals 4 times 4, 16, times y plus 3, and this will be our final answer. Number 2, write the equation of the parabola, x equals 5y squared minus 10y plus 2, in standard form. So again, in standard form, that's what we did up here. Where you have the squared term isolated by itself, usually on the left side of the equal sign, and everything else on the right-hand side with your y minus k term or your x minus h term being a binomial in parentheses as well. So the first thing I notice is that I have a y squared term. So that means I want to isolate all of my y's to one side of the equal sign. So I'm going to leave them I'm basically just going to leave these two y's where they are and move that 2. So if I do that, I get x minus 2 is equal to 5y squared minus 10y. And again, this is just preference. I prefer to have all of my squared terms on the left side. So I'm literally just going to swap these two sides and put my y's on the left. In doing so, I've also got to complete the square because your squared term cannot have an a value other than 1. So I'm going to factor out a 5, and that leaves me with y squared minus 2y. I'm going to leave me a space for new c is equal to x minus 2. So we're going to go ahead and find that new c by doing b over 2 squared. So it'll be negative 2 over, no, it's not negative, sorry, negative 2 over 2 squared, which will be negative 1 squared, which is 1. So we're going to add 1 to the left side, and then it's technically not 1, right? This 5 is also being distributed in. So on the right-hand side, we're actually adding 1 times 5. And then we do that. We end up on the left side, our y trinomial, y squared minus 2y plus 1, can be rewritten as y minus 1 squared. Oh, and I still have that 5 on the outside. Is equal to x, and then negative 2 plus 5 is 3. And the only other thing to do to get it into standard equation, which again looks like this up here, is to move that 5 to the other side. So I'm going to isolate y minus 1 squared. I want this x plus 3 to also remain as a binomial with nothing else being distributed in. And then if I'm going to move the 5 to the other side, it would be like dividing by 5 or multiplying by 1/5. So this would be our final answer of that parabola in standard form. Number 3, identify the coordinates of the vertex and focus, the equations of the axis of symmetry and directrix, and the direction of the opening of the parabola with the equation y equals 2x squared minus 4x plus 5. So the start of this question is very, very similar to number 2. In order for me to find all of that other information, I want to go ahead and get this parabola into standard form. In doing that, I'm going to go ahead and again put my x's on one side of the equal sign because I noticed that the x is the squared term. Then the last question, the y was the squared term. So if I'm going to put the x's together, it'll be 2x squared minus 4x on one side of the equal sign. And even though I'm writing it technically on the left side, I'm keeping it positive and just switching the two sides of the equal sign. And then if I move the 5, it'll be y minus 5. Okay, to get it into standard form, I'm going to factor out a 2 from my x's. And I get x squared minus 2x. And I'm going to need to complete the square, so I'm going to leave me some room for a new c. So to find that new c, I'm going to do b over 2 squared, which will be negative 2 over 2 squared, which will be negative 1 squared, which again is 1. But this time when we add 1 to complete the trinomial, the 2 on the outside is being distributed in. So on the right-hand side, I'm actually adding 1 times 2. And then that gets me 2 times x minus 1 squared is equal to y. Negative 5 plus 2 will be negative 3. And then again, in standard form, we don't have any coefficient way out front, so I need to move that 2 to the other side. So if I do so, it'll be x minus 1 squared equals, I want to leave my y minus 3 as a binomial like that. So when I move 2 over to the other side, it'll be in the form of 1/2. Okay, so this is the equation of our parabola in standard form. Now let's go back and identify the things that it asks. It wants us to identify the vertex. So remember that comes from our h and k. So if it's x minus 1, h is going to be positive 1. Y minus 3 means k is 3. So there's the vertex. To get the focus of a parabola, so a couple things to note. Notice our x square, or the x term is the one that's squared, and p is positive, right? Even though we don't necessarily know what p is at the moment, because it's a positive thing right here, we know that. So we can also go ahead and add right now that we know this parabola opens up. And then to find the focus of a parabola that opens up where the x term is squared, the focus is found by h, comma, k plus p. So in order to find that, we need to solve for p. Well, as the standard form of the equation is written, we don't know what p is, but we do know that this coefficient of the binomial on the right side is equal to 4p. So if I know that 1/2 is equal to 4p, If I divide both sides by 4, or think about it as multiplying both sides by 1/4, might be a little bit easier. 4 times 1/4 is 1, it cancels. 1/4 times 1/2 is 1/8. So if 1/8 is equal to P, then that means our focus is, we know that H is 1, we know that K is 3, plus P is 1/8. And again, I want to use this question as a reminder that you cannot use the graphing calculator on your test. Therefore, you need to be able to add numbers like 3 plus 1/8 by hand. So if I need common denominators to add, I'm going to multiply 3 by 8/8. So 8/8 times 3/1 is going to be 24/8 plus 1/8. Therefore, we get the coordinate of our focus, which will be 1, 25/8. So there's the focus. So let's see, I've got the vertex, I've got the focus, I got the direction of the opening. So I need axis of symmetry and directrix. Well, we know that the axis of symmetry goes through the vertex and the focus, which the vertex and the focus both have the x coordinates equal to 1. Therefore, the axis of symmetry is the line x equals 1, not just the number 1. Please make sure you put x equals or y equals depending on the orientation. Okay, lastly, we have the directrix line, which is found by y is equal to k minus p. So that's going to be y is equal to k, we know is 3, and then we solve for p, which is 1/8, so 3 minus 1/8. Well, again, if you multiply 3 times 8/8, then you'll get 24/8 minus 1/8, and you'll get the equation of the directrix line, which is y equals 23/8. And I think that's it. Equations of axis of symmetry and directrix. Yep, so we found all the elements that we needed. Number 4, write the equation for the circle with a center of 1/2 -2 that is tangent to the x-axis. So change of conic section here, we're dealing with a circle. So first thing to recall is that the equation of a circle in standard form is x minus h squared plus y minus k squared is equal to, oh, sorry, not 1, r squared. So I give you the center. I'm giving you h and k already. This is the part that you need in order to find r. If it's tangent to the x-axis, that means it intersects the x-axis exactly 1 point. So you can kind of sketch out this scenario. The center of the circle is at 1/2 -2. So if this is the center of the circle, and the circle is tangent to the x-axis, the only way that it will intersect the x-axis only once is if it intersects the x-axis directly above here, right? And then it'll intersect it over here and down here to make the circle like this. Well, in drawing this little sketch, that tells me the radius. The x-axis and that center point are 2 units away. So that must mean that the radius is equal to 2. So if I have hk, I know the radius is 2. I just plug in those 3 variables, and I get x minus h is 1/2 squared plus y minus -2 will change to y plus 2 squared is equal to r squared. So 2 squared will be 4. And guys, that's an easy place that people make mistakes, is they forget to square the radius, or on a multiple choice question, they forget that equations of circles are equal to r squared. Okay, number 5 and 6 are similar to each other. I just ask you to graph a certain equation, but I don't tell you what the graph is going to look like or what shape it's going to make. So that's where you have to know your chart. Again, I want to remind you, you're allowed to make a 3x5 index card for your test with whatever information that you want on it. That one of the keys, or one of the things I would definitely make sure that I write, is the day that we did all of the conic section comparisons, where we looked at the value of A and C for each of the conic section equations to figure out, okay, which conic section would this graph. So for number 5, if everything is equal to 0, so again, I could just move this 4 to the other side, it'd be -4. That has no implication on A and C. A and C are the coefficients of x squared and y squared. So the coefficients right now of these are both equal to 1. So if A is equal to C, then that implies that this conic section is going to be a circle. So that kind of tells you what equation you're going to try to morph this into to get it into standard form to be able to graph it. So once you deem that it's going to graph a circle, the standard equation for a circle we wrote up in number 4. So that's going to be I'm going to have to complete the square. So I'm going to group my x terms together. X squared minus 2x. I'm going to leave some room for a new c. Plus group your y terms. Y squared plus 4y, room for a new c, is equal to 4. Okay, for our new c's, we're going to take b over 2 squared. So negative 2 over 2 is negative 1 squared, which is 1. So if I add 1 to the x trinomial, I'm going to add 1 to the right-hand side of the equation. And then for the y's, b is 4. So 4 over 2 squared will be 2 squared, which is 4. So if I add 4 to the y trinomials, I'm going to add 4 to the right-hand side as well. So then when I rearrange this, I turn my trinomials into binomial squares. So this will be x minus 1 squared plus y plus 2 squared is equal to 4 plus 1 plus 4 is 9. So this is the standard equation of our circle. Once it's in this format, then we know that x minus 1, y plus 2 stands for our center point, which will be positive 1, negative 2. So 1 on the right down 2. And we know that 9 stands for r squared. So if r squared is equal to 9, that implies that the radius is equal to 3. And once you find that value, you'll graph 3 to the right, 3 up, left, and down. And then just do your best to sketch the curve to hit those 4 points. Okay, number 6, graph 9x squared plus 16y squared equals 144. Again, in order to even know what graph this is going to make, we need to look at a and c, which are the coefficients for x squared and y squared. So coefficient for x squared is 9, coefficient for y squared is 16. So they're not equal, so this is not a circle. This is going to be the scenario where a and c, we'll say a is not equal to c, and both are positive. So if a is not equal to c and both are positive, then that implies that this equation stands for an ellipse. Once you know that it stands for an ellipse, then you know what you're trying to morph this given equation into the standard form of. Hopefully that's one of the things ingrained in your brain by now. An ellipse and a hyperbola must both equal 1. So if it must equal to 1 right now, it is not. So in order for that to happen, if I've got 9x squared plus 16y squared equals 144, and it needs to equal 1, then on the right-hand side, in order for 144 to get to 1, I need to divide everything by 144. Okay, in doing so, for the x's, it's like simplifying 9 over 144, which will be 1/16. So then I get x squared over 16, plus if 9 went into 144 16 times, then for the y's, that means 16 is going to go into 144 9 times. So that'll be plus y squared over 9 is equal to 144 divided by 144 is 1, which is the reason that we did it that way. Now, to graph an ellipse, the terms on the bottom, these are always going to stand for a squared and b squared. And these are kind of like the major and minor axis radii. So that means if x squared term is first, that means our ellipse is bigger in the x direction because a is always bigger than b in an ellipse. And under x squared is 16, so that means a must equal 4. So again, the center point is at 0, 0 because I have no x minus h and y plus k, or y minus k. So if a is equal to 4, that means in the x-axis direction, we go 4 to the right and 4 to the left. Under y squared is 9, which means b must equal 3. So in the y direction, we will go up 3 and down 3. And there's our ellipse. Okay, for questions 7 and 8, state whether the graph of each equation is a parabola, circle, ellipse, or hyperbola. State the values used to identify each conic section without writing each equation in standard form. So guys, these questions here are exactly what we did for 5 and 6. You basically need to look at the A and C values of your equation and figure out their relationship, and that's going to tell you the conic section. So before you need to do that though, you have to make sure that your equation is set equal to 0. And there's nothing that's like being divided out or anything like that. So I would go ahead and let's move everything on the right side to the left side. So I've got 2x squared minus 10x. I'm moving everything from the right to the left, so it'll be minus 8y plus 2y squared minus 5 equals 0. So I repeat, when you compare A and C, everything has to be multiplied out and everything has to be on one side of the equal sign. Now, there's nothing being multiplied out. There's nothing we have to distribute. So once everything is set equal to 0, then you can go ahead and look at A and C. Well, A is 2. A is always the number in front of your x squared term. C is always the coefficient in front of your y squared term, which is also 2. So since A is 2 and C is 2, anytime those are equal, we're going to have a circle. For number 8, there are a couple things that we need to do before we look at A and C. First is going to be we need to go ahead and distribute out y minus 2 squared. So in order to not confuse myself, I'm going to literally write out 3 times y minus 2 times y minus 2 minus 8. And then while I'm at it, I'm going to go ahead and take the stuff on the right hand side and move it to the left hand side. So it'll be minus 9x plus 10x squared equals 0. Now, when you multiply this out, so this is actually going to be 3 times. When you multiply y minus 2 times y minus 2, first out of interlast, it's like foiling, right? You get y squared minus 2y is minus 4y. Negative 2 times negative 2 is plus 4. None of these are like terms or anything, so minus 8 minus 9x plus 10x squared equals 0. And then we need to distribute this 3. So then we get 3y squared minus 12y plus 12 minus 8 minus 9x plus 10x squared equals 0. Now, if you want, you can add terms like 12 and negative 8. Those are the only two that are common, but that's not going to have any implication on A and C. A and C are going to be your variables in front of the squared terms. A is going to be 10, and B is 3. So since A is not equal to C, but they are both positive, so since A is not equal to C, but both positive, then that implies that we have an ellipse given by this equation.